Lend your time and attention towards this video so that all your confusion will be blown away, and this topic will be going to be easy with all my tips and tricks. And let's get into today's video, which is on non-exact differential equation. See here, in this video, I am going to discuss about the solution methods, and this topic is from differential equations of first order and first degree. And let me explain you what is a non-exact differential equation. See here, when the equation which is of the type, see here, m dx plus n dy is equal to 0. If an equation which is of the type m dx plus n dy, see here, we have to select m as well as n from the question. See, m as well as n. So here I am going to make a derivative with respect to y for m, that is dou m by dou y, and here I am going to make a derivative with respect to x for n. If both the values are equal, then we say that the equation is an exact differential equation. Clear? And next one, the same thing, if dou m by dou x. So here, if I make a derivative with respect to y for m, and if I make a derivative with respect to x for n, if both the values are not equal, then we say that differential equation is non-exact. See here, clear? It's a non-exact differential equation. If this equation, if you pick m and n, and if you calculate dou m by dou y and dou n by dou x, if both the values are equal, then we say that it's an exact differential equation. And if both the values are not equal, then we say that it's a non-exact differential equation. See here, in order to make a non-exact differential equation into differential equation, so into exact differential equation, see here, observe. So in order to convert this non-exact differential equation into exact differential equation, so if I multiply with a term, so if I multiply the equation with a certain term, so this non-exact will become the exact differential equation, and the term is called an integrating factor. See, this is most important for solving non-exact differential equation. What is this integrating factor? So in order to convert this non-exact differential equation into exact differential equation, so we multiply with a certain factor, and that factor is called an integrating factor. Clear? And next, after converting into exact differential equation, there is a formula for finding a solution. That is integral m dx plus integral the terms not containing x in n of dy, or the terms independent of x in n of dy is equal to 0. See here, what are the solution methods for finding the non-exact differential equation? So here I am talking about the solution methods. So there are 5 types of solution. So solution methods. So generally there are 5 types of solution methods here. The first one is the inspection method. The first one is inspection method. And the next one here is using integrating factor. See here, using IF. So which IF I have to use? 1 by mx plus ny. So here first integrating factor is 1 by mx plus ny. And the next one here is using integrating factor. So using IF. So which IF I have to use? The third method is 1 by, see here, 1 by mx minus ny. And the next one, fourth method here is, so fourth method here is using the integrating factor. See, using the integrating factor, that is e power integral g of y into dy. So how we get this g of y? So g of y is nothing but 1 by m times of. So if I start with m, so we have to go with n. Dou n by dou x minus dou m by dou y. So if you calculate this one, we'll be getting g of y, and the integrating factor will be e to the power of integral g of y dy. And the fifth method is using the integrating factor. See here, the fifth method is using EF, the integrating factor. Which integrating factor? That is e power integral f of x into dx. See, what is f of x here? So f of x value is nothing but, so f of x value is nothing but 1 by n times of. So if you start with n, so we have to go with m. Dou m by dou y minus dou n by, the value here is dou x. So these are all the 5 type methods for finding the non-exact differential equation. So we have to transform this non-exact differential equation into exact differential equation, and we have to go with the formula. That is, I'll tell you. So after changing into exact differential equation, what is the solution formula here? Integral m dx plus integral terms independent of x, terms independent of x in n of dy is equal to c, or the terms not containing x. See here, the terms not containing x in n of dy is equal to c. So here, this is the solution formula here. So here, what is a non-exact differential equation? When m dx plus n dy is equal to 0 is the equation. So if you calculate dou m by dou y, which is not equal to dou n by dou x, then we say that the given equation is a non-exact differential equation. And how to find the solutions for this non-exact differential equation? So generally, so we'll go with an inspection method. So there are few formulas here, so I'll tell you in my next video. So after choosing those formulas, and we have to integrate on both sides and get the solution. So the next, the second type is using the integrating factor. So what is this integrating factor? Integrating factor is, in order to transform a non-exact differential equation into exact differential equation, so we multiply with a certain factor, and that factor is called an integrating factor. So here are the integrating factors. First one is 1 by mx plus ny, the second one is 1 by mx minus ny, and the next one is the integrating factor e to the power of integral g of y into dy, and next one e to the power of integral f of x into dx. So these are the 4 integrating factors, and one is the inspection method. So after using this one, after using these integrating factors, so the non-exact differential equation is transformed into exact differential equation, and this is the formula for finding an exact differential equation, that is integral m dx plus the term independent of x in n of dy is equal to c, or else the terms not containing x in n of dy is equal to c. So this is the solution, and this is how I am going to solve. In my next video, I am going to start the inspection method. All the formulas are vividly explained, clearly explained, so you will get a crystal clear clarity after watching that video. And for each and every integrating factor, I'll give you some tip here. So in order to select the integrating factors so easily, so here there will be no confusion if you follow one after the other video, and it will be damn easy to follow this exact differential equation, as it is very important topic. And definitely my playlist will be very, very helpful to you, and please pass it on to as many friends as you can. That is the greatest help needed to this channel. And stay connected, and I'll be uploading very, very soon. Thank you, and have a look at it.